Hello everyone, welcome to Projects with Gaurav, and today we are going to start the part 2nd of lecture 4th of machine learning series. In this lecture we were studying about how we classify the machine learning models. So there are 5 key components on the basis of which we classify our machine learning models. So these are based on input data, problem statement, algorithm solution and output data. So in previous video we discussed this input data classification in detail. So I would recommend you to see it, and if you have any doubts, do post in the comment section. So moving on, now we will discuss the second bifurcation, which is nature of problem. In this, there are 3 subcategories, which is classification problem, regression problem, and clustering problem. Now, what happens with each one of them? In classification, what it is that you are given inputs and outputs, and you train a model so that it can predict in which class in the given output. Let's suppose there are 3 classes, so 1 2 3. So if a new input comes, new input, so model will be able to tell us that okay, it belongs to a class 1, class 2 or class 3. In regression problem, what happens is that, let's suppose you are predicting price of a house. So let's suppose you are doing house price prediction. Now in house price prediction, what happens is that there are no particular classes in house price. So house price can be, let's suppose, 780k dollars or anything. So when model predicts the continuous output like this, it is called a regression problem or regression model. In clustering, it is kind of same with classification problem, but what happens is that in clustering, this output is not given to us. It is not given to us. Model itself decides, okay, how many number of classes will be there, and then it divides the given input based on its parameters, that okay, in which class the input should be put in, or what is the class that input should be assigned. So it's the same thing I have written here. Let me change the color of pen. Yeah. So classification problem, in this class labels are needed to be assigned to the input data. The goal is to teach algorithms to accurately assign appropriate class labels. In regression problems, what happens is that it is used for problems involving prediction of continuous variable. See, I was telling you here that this is a continuous variable, this 780k. In clustering problem, what happens is that it is the problem that involves machine learning algorithms to divide a set of data into specific number of groups. So there are data samples. Wait a minute here. There are data samples which you divide in specific number of groups. It can be anything, and you can train a model based on like a certain data that okay, it could also predict that how many groups will work. Now let's move on to next bifurcation, which is nature of algorithm. So on the basis of nature of algorithm, machine learning models are divided into 3 categories: classical machine learning, neural networks, and deep learning. Now let's see them in detail. So classical machine learning models are the algorithms that use statistical and mathematical equations to analyze the relationship between input and output data. So what they do is they try to put a mathematical function in input and output data such that you can make a prediction. For example, there are certain examples like SVM and decision tree. So I'm using decision tree example to explain. Let's suppose you have an input data. So decision tree, what it does, it bifurcates based on that okay, on a particular parameter. Let's suppose again the house price prediction. So in this, first of all, like, is this house is having a pool? No, yes. So that's how it divides. That's how the tree continues, and we get an answer. In neural networks, what happens is that the structure and the function of human brain inspires these algorithms. So they use complex mathematical models with many trainable parameters which are learned through the training data. So these are also mathematical models, but the inspiration, the structure and the function, they perform like human brain. In deep learning, what happens is that the principle is same as neural networks. So you can say that okay, these two are based on same principle, but there are certain limitations in neural networks, but with deep learning you can overcome them. This is actually an improved architecture which was developed to overcome the limitations of neural networks. Now let's move on to next bifurcation, which is nature of solution. So on the basis of nature of solution, there are two models. First is parametric. Wait a minute, let me change the color again. First is parametric model and second is non-parametric model. So what are these? Parametric models are the models which only consider the future inputs to make predictions about the output. So what these do is they rely on the patterns they observed in training data and assume that the same patterns will apply to new unseen data. For example, let's suppose in a problem there was a variable x, like there were certain variables x1, x2 up to xn, and there was an output variable y. So in training data, what was happening is that y was linearly varying, linearly varied with x1. This x1 and this y can be anything. I'm just taking an example, a very generic example. Like with respect to x1, y was varying linearly in training data. But what can happen is that in test data, this relation might not hold true. So that's why these are kind of some of the limitations of parametric models, that they only depend on future inputs and the training they had. So they assume that okay, the data coming will also follow this pattern, which can be or cannot be true. This depends on the problem. So there are certain examples like linear regression and neural networks. Now, what are non-parametric models? In this, the output of the prediction depends on both input features and the previous outputs predicted by the model. For example, let's suppose you made a model and you trained it. So training happened. After training, what happened is that there is test data. So whenever it make a prediction on test data, it will update its function based on what the test data was there. Like if it can found some new parameters, some new patterns, it will update its training. So these models actually derive the predicted output value from output values that existed in similar scenarios in training data. So what they do is they store kind of a table with inputs and outputs. So whenever test data comes, they check whether the same condition occurred in input or not, and then they give the output. They also sometimes update themselves. They can update this table. This again depends on how you train your model. So there are certain examples like KNN and decision trees. Now let's move on to next bifurcation, which is also the last bifurcation, which is nature of output data. So on the basis of nature of output data, there are two models. First is probabilistic model and second is non-probabilistic model. In probabilistic model, what happens is that the output produced is in probabilities. What does that mean? Is that it produces output in probabilities which include the confidence score. For example, let's suppose there are 5 outputs, 1, 2, 3, 4, 5. And the model will say that okay, it has a 0.9 score for this. This 0.9 means 90% confidence that the given input has an output 3, and the rest it can be like 0.05, 0.050 and 0. So that can be the output it will give. So what we do generally is we take the category with highest confidence. So for example, in classification problems, the algorithm predict a label with certain degree of confidence. CNNs or convolutional neural networks are one of the best examples of this probabilistic models. So they are not kind of 100% sure, but yes, they give a confidence score for the given output. Like in this example, the model is 100% sure that it is not 4 or 5. It is kind of confused between 1, 2 and 3, but even in that, it is quite sure that it is 3. So that's the thing. Now, in non-probabilistic models, this category of models predict the output, but it does not measure the prediction quality. Let's take the same example. Here we have 5 outputs again, 1, 2, 3, 4, 5. So it will say, okay, 3 is my output. It will not give me any confidence score. For example, let's suppose in this case, let's suppose the confidence score is 0.5, 0.1, 0.1, 0.2 and 0.1. So check these scores that they add to 1. So 0.1, 0.7, 0.9, yeah, they add to 1. So it is kind of only 50% sure. Let me kind of clear it so that you can easily see. Sorry, not 50, it is kind of 60% sure. So I have changed the probabilities. It is only 60% sure, but in previous model it was 90% sure. So this is kind of a more accurate model than this. This is just an example. It also depends on the type of problem you are solving, the type of input data you are giving. So that's also a combining factor. So there can be some external methods which we can use to determine the error between actual values and predicted values. So one of the external methods which is used is mean squared error, mean mean absolute error, confusion matrix, confusion matrix, and so on. So some of the examples of these are decision tree and support vector machines. They fall under this category. So that's the end of this lecture. I hope you enjoyed it. If you have any questions, do post them in the comment section. I will try to reply them as soon as possible. Till then, bye.